Hello again, this is Kaylee Gonzalez. I'm with MLC CAD Systems. Welcome back to our video series on the CSWA sample exam. So if you haven't been following me from the very beginning, I do have a previous video that I completed that covers questions 3 and 4 of the sample exam. That is going to provide us with the base model that we're going to use to make our design changes on in question number 5. What I have open on my screen right now is from the sample exam PDF that I downloaded from the Solidworks website. This is giving me the changes that I need to make in my model. So they're giving us several different types of isometric views. They also gave us a top, a front, a right, and a section view, which details that radial cut through the middle. One of the most challenging portions of these exams is trying to interpret all of the information that they provide you on a time limit. So take a breather, look really closely at the information that they provide before you start modeling. Now, a couple of things with this particular model. One is the radial cut is not going to be symmetrical. We can see that inside of the top view. We have a 12 millimeter thickness at the top, but not at the bottom. So that's not going to be a symmetrical cut. Another item that is very often missed is the center point of the 41 millimeter radius needs to be vertical to the right edge of the part. If that sketch relation is missed, you have the potential of cutting too much or not enough material away, and that can throw off the mass of your part in your answer. If we take a look at question 5, we can see that they're telling us to use the part we created in the previous question and modify it by removing material and changing the following parameters. Remember that A, B, and C are being driven by global variables and equations, so they are slightly different in this question than they were in the previous, so we just want to make sure we don't forget to update that information also. So now that we've taken a look at the different views, we are aware of some of the issues that could happen. Let's go ahead and jump into SolidWorks and start removing some of this material. So as we go into SolidWorks, the part that I have open was where I ended on question 4. So I'm going to start from here and I'm going to start making my way through the various changes that they have provided for us on question 5. So I'm going to start making some of these cuts. I'm going to sketch directly on faces. This I think will be easier for you guys to follow because we're not going to need the origins to be placed exactly the same. So I'm going to open up a sketch directly on this particular face here in blue, and I'm going to use my flyout window in order to create that sketch. Now, sketch relations are going to be your friend in this exam. You should be really good at sketch relations anyway, but if things are not lined up correctly, again, your cuts could be off by a little bit. So I'm going to make sure that the first corner of my corner rectangle is going to be in this upper left-hand corner, so I can see my coincidence symbol. This is going to constrain two sides of my rectangle because they're constrained to the model itself. So I can add my dimensions that have been provided to us. So the height of that's going to be 19, and then the dimension is from the remaining royal blue line to the right edge of the part, and that's going to be 52. From here, I'm ready to go into my cut extrude, and this is going to be through all, so it cuts through all of the material. Now my second cut is going to be sketched directly on this face here in blue, again using my flyout window. I'm going to follow the same steps I just did. I want to make sure that the corner of my corner rectangle tool is going to be coincident with this corner on my part. This is going to help guarantee that my edges are going to be lined up correctly and I'm not going to end up with any additional bodies or accidentally not cutting enough away. Same thing here. I want to make sure that I have a sketch relation of collinear between the bottom edge of my sketch and the bottom edge of the part. Again, this is going to fully constrain my sketch. So when I go to actually make this cut, it'll cut through successfully and provide us with the same type of bottom isometric view that we were provided in the PDF. The next cut that I'm going to address is going to be that radial cut. Now we know that it's not going to be symmetrical through the middle of the part. I'm going to sketch this on the back side of the part. Now, I like items to be oriented the same way that they are when I'm taking the test. It's just one less thing for me to have to remember. So I can right click on my sketch and then say normal to in the tree, and that will flip this so my orientation is correct. I'm still sketching on that back face though. And I'm going to start with my corner rectangle tool, and I want to make sure that I'm going to start coincident to the top edge and then end coincident to the side edge. Now don't accidentally constrain this to the midpoint. That will cause issues for you that you will then have to troubleshoot and go back and try to fix and change. So it's not actually going to the midpoint. I'm going to add my dimension of 41 millimeters. And again, we want to make sure that the center of this radius is going to be coincident or vertical with this right edge of the part. That's something that cannot be overlooked, because as you can see, this really changed the orientation of this particular cut. I am going to close this sketch, and I'm making use of my reference lines to create these sketch relations. Now, I did happen to miss one. I'm going to add another collinear relationship to make sure that this is going to be fully defined. And my last dimension of 36 will be added. So if I go into my features tab and I access the extruded cut, I don't want this to be from the back face that I selected, but I can add an offset to that directly in my cut extrude property manager. So I'm going to add 12 millimeters, and I have to reverse that direction so it's going into my part, and then I can add my depth of 24 millimeters. And that will give me my desired cut. The next step I have to do is add the 11 millimeter hole that is part of our design changes, and we want the center of that hole to be lined up with the right and top edges. This is going to be a through all cut. Now, I also want to make sure from here, I need to go into my equations and I need to adjust these values to what they have specified for question 5. So letter A is going to be 86, letter B is going to be 58, and letter C is going to be 44. I don't need to change the material, so from here I have all of my changes completed. If I go under my Evaluate tab, I can choose my mass properties, and we can see that my mass is 628.18 grams, which is identical to the answer key. So we verified that our changes are correct, and that's going to properly set us up for the next question, question number 6. So I'll see you again in that next video. Thanks for watching.